So let's continue with our transmission conduction load estimations. And let's say we are going to take an example question now for us to get more understanding. And let's say the given values for our building are, let's suppose it is a building on our campus, and for the building the values are given. So for the roof, U of the roof is mentioned, U of the walls is given to us, U of the window is given to us, and for us, because I am currently in US and studying in US, and the industry over here follows all imperial units in building energy calculations, all air conditioning, and basically the HVAC. I'll be using the imperial units, but specifically I'll also put in another video where I'll use all the SI units for you to get more understanding if you are more used to using the SI units. So for the roof, my U value is given to be as 0.05, and these are all standard values taken from S-ray or some other standards. So these are standard. It could change. BTU per hour, degree Fahrenheit, and feet square. For walls, the value is given as 0.1 BTU per hour, degree Fahrenheit, feet square. For windows, it is given to be 1.1 square. Okay, and the building orientation is given to me. So my building is something like this. It's lengthwise long, and the areas are available to me. Let's suppose the areas are available to me. The lengths are given. The length is 220 feet. This is 350 feet, and the height is 45. Okay, and for the area of windows, so basically for each of the walls which we have, the 4 walls which we have, what we'll assume is the area of window is 10% of total wall area. So what does that mean is, if I have this wall of 220, this front wall of 220 feet by 45 feet, what will happen is the total area will be 220 into 45 feet square, and my area of window will be 0.1 times the area total, and my area of wall will be 0.9 times the area of total. And this applies to each of the orientations, so each of the walls which we have, the 4 walls. Okay, and for infiltration part, so these are the 3 conditions which we had to take. The other, obviously, which we missed is U of floor, and it's so small a value, so we'll usually ignore it. Or ground, floor or ground. And then for U into A of infiltration is there. Now it depends on rho V into Cp. For this, the U into A values are to be used. For the infiltration, U into A of infiltration, rho V Cp will be used. And for V, that's the volume flow rate, we'll use the ACH. What's the ACH? It's air change per hour. So we may have in a building 1 air changes per hour. That means the total air inside my building will be changed once in 1 hour. If it is 5 air changes per hour, that means the total air in the building, let's say the building total volume is going to be 220 into 350 into 45 feet cube. This is not feet square, sorry. It's that amount of volume. Then if it is 5 ACH, that means the total air in the building will be changed 5 times. So every 12 minutes, the total air in my building, it's going to change. I'll have a fresh air coming from outside. That's the ventilation thing happening. So the rho VCP is available, and for the infiltration part, we are given that there are 0.5 air changes per hour. What does that mean is 0.5 U into A will become rho of an air is constant, that value is 0.074 into 0.5 air changes. That means 0.5 into the volume of my building, which is 45 into 220 into 350 into the CP value, right? The CP value for air is 0.24, and hence this value comes out to be 30769.2, and these points and decimals doesn't matter over here because the values, total values are going to be 10 raised to 6 or something. So this values doesn't matter, the decimals. And U into A unit will be BTU per R degree Fahrenheit, right? So we have the U into A. For the other parts, the roof, windows and wall, what we need is, we need a table. So we'll make a table where we have the wall, window, roof, ground or floor, and infiltration. And what we need is, for wall, windows and all, we need U into A values. U value, then A value. And we do not need specifically for each direction, because the windows area and wall area over here is specifically mentioned as 0.1 and 0.9, that is 10%. If it is not the case, then if areas are going to be individually different for each orientation, then we need to separate out the orientation for wall and window for each orientations of the wall and windows there. But since it is going to be a constant 10% and 90%, it's going to be simple for us. And let's just make this a narrower column, because we need a large value. So for walls it is given as 0.1, for window it is given as 1.1, for roof it is given as 0.05, and for ground a total infiltration value is given, U into A for us, and for infiltration, for ground and floor, the UA total of ground or floor is given, and U into A for infiltration we already figured out. So over here these values will not come. And it is very good practice if we also write the units. So each of the columns would be written with a unit. So this is BTU per hour per degree Fahrenheit per feet square. Now the second thing which we have is A, area. It's going to be constant over here for us. So area of the wall will be 0.9 times the total. So the total would be 220 into 350 plus 45, 220 into 350, sorry, that should not come. I made a mistake there. So this front wall will be 220 into 45 into 2, because that, and the back side, and the other would be 350 into 45 into 2. So that's the total area, into 0.9 because that's the 90%. This gives the total area, but we need the opaque part of it. That's the actual wall. So we'll take the 90% of it. For windows, this factor remains the same, but it is just 0.1 times the same factor. Right? For roof, the area is going to be 220 into 350. Now we'll have the U into A calculation. U into A. So for walls, the U into A comes out to be 4617. For roof, it comes out to be 3850. For windows, it comes out to be 5643. And for ground and floor, it is given to us a constant value of 1000. And for infiltration, it comes out to be 30,770 approximately, right? So you see, a very high value of infiltration is there. UA infiltration has a very high contribution. UA from ground has a very small contribution. So from further calculations, maybe in the next example or when we do another estimate of the building steady state loads, we can ignore the ground UA value. Roof, windows and walls are comparable over here, but they will be specifically too much dependent on the specific areas of wall and window. So we can't directly make an estimation of window, wall and roof if we want to ignore them and not. But we can definitely say the UA from ground or floor can be easily ignored. And if there's an infiltration, then we cannot ignore it. It has a very large contribution. So the total of UA comes out to be 45,880, an approximate value again. And this is U into A, which means the unit should be BTU per hour into degree Fahrenheit. Now we just need to use the standard expression, which is Q is equal to U A T in minus T out, or the other way around. This could be plus minus. That completely depends on what the condition it is. It is a heat gain or heat loss. Okay. So now let's do the calculation. My U into A for U into A into delta T is, I'm not sure what this problem is. Okay. So total U into A is 45,880. And my temperature values could be, let's say we have a heat gain. So outside temperature is higher. Let's say outside temperature is 90. And so this is my T out. And my T in, let's say I want to maintain 75 degrees inside my home. So my total heat gain in that case would be 68,8200. That is the amount of BTU per hour. And that's the heat gain rate inside my building. That's the amount of heat gain which is happening. And I am so sorry if it's not visible to you. Let me use another marker. 45,880, 90 minus 75. 90 is the T outside, T in is 75, and this Q dot comes out to be 688,200. And the unit is very important. It is BTU per hour. So we can see that it is coming out to be 688 kBTU per hour, or 0.69 MMBTU. That is metric million BTU per hour. Okay, so I hope you have got a basic idea of how to do all the calculations over here for conduction heat transfers from the transmission or from the envelope. In the next video, we'll go into the second load, which is the solar load, and we'll see how the solar heat gain factors, solar heat gain coefficients and all orientation thing comes up, and how to read charts and all. So thank you. That's all.